everyone, this video is going to help with two variable relationships. And what is a two variable relationship? So it's when I have two things I don't know in an equation. So right now we've been solving equations that had one letter, usually an X or an A or a B or whatever letter we wanted it to be, that variable, and we would find a number that represents that. Well, with two variable relationships, there might be more than one combination that works. And so that's kind of what we're looking at in this section. And we're going to start with just what is a two variable relationship. So let's look at one example here of something that is that does have two variables, and we'll write out that in equations as an equation. So let's say we're going to the store, and at the store we are going to buy 12 pieces of fruit. And only buy apples. I keep forgetting the U in there. Buy apples and pears. So I'm going to the store and I'm going to buy 12 pieces of fruit, and I only want to buy apples and pears. All right, what don't I know? What are the two variable things? Variable means that they could change. They don't stay the same. You can let a letter represent them, but they're things you don't know in this word problem. So what don't you know? Well, you don't know how many apples and you don't know how many pears. So let's let a variable represent the number of apples. I'm just going to use an A. So this is the number of apples. And then let's let the P equal the number of pears. Okay, so we have the number of apples, the number of pears. How would I write an equation that represents this situation? Well, we know however many apples plus, right, however many pears has to equal 12. So let's write it as A plus P has to equal 12. Now, that isn't the only way you could write this equation. So I want you to think about equivalent. That means the same. Equivalent equations to this one. What else would be equivalent? Well, I could have apples is equal to 12 minus the pears, because I know, well, there's 12 total. If I take off the amount of pears, that has to be our apples. Same idea for pears. So pears would equal 12 minus the apples. So this is three different ways to write the same situation here. So there's not, if you look at the answer key, you might have to, they may have one or two answers that work for them. I think they're pretty specific on this answer key, but you could have more than one. All right, so let's look at one more word problem situation. What if I go to practice after school? And it is 90 minutes, so practice is 90 minutes where I do a mix of warm-ups and drills. So practice is 90 minutes, and I'm going to do a mix of warm-ups and drills. What do I not know? Well, I don't know how much time I'm going to warm up and how much time I'm going to do the drills, right? So W could be our time for the warm-ups, and D can be our time for the drills. How would I write that with the 90 minutes? It would be, well, we have our warm-ups plus our drill time plus our total time. So they all have the same kind of unit, that's why I was saying that. But all right, so we have W plus D equals 90. And again, you could find equivalent equations to that situation as well. So what we're going to also look at is two definitions of dependent and independent variables. So dependent variable, what is the definition and what is this? What am I talking about? So this is changes in response to another variable. An independent variable the definition of an independent variable is it affects the change on that dependent variable. So it affects change on the dependent. Okay, so let's look at some quantities and some different things that we want to try to represent them as either independent or dependent. Let's say you biked M miles to the store and burned C calories. You also notice I am walking you through the printed notes. That way you have them for some of you want to look at them as we go through this. So I'm going to let my first example be you biked M miles to the store and burned C calories. All right, so how do we know which one is what? So we biked M miles to the store and we burned C calories. Well, we all probably know, oops, I didn't put that up high enough. Sorry. We all know that the more you bike, the more calories you burn. So which one is dependent on the other? Well, the calories burns depends on the number of miles you bike, right? So the more you bike, the more calories you burn. The less you bike, the less calories you burn. All right, so in the book they said underline the independent variable. So we're going to underline the independent and circle the dependent. All right, so in this situation, the dependent variable is that calories burned, and the independent is the miles, right? The more miles. So that's how we find that. What if we have a situation that says, I wonder if you could see this so that I don't have to write it because I'm lazy. I'm not really lazy. It's actually just trying to be more efficient. Okay. Other than my camera broke, so it's like takes me a sec to get it the right way. So I just did A, so let's look at B here, the second question here. The category of a hurricane is related to the wind speed of the hurricane. So the category of the hurricane is related to the wind speed. So which one is dependent upon the other? So the category, right, depends on how fast that wind is whipping around. So the way that I would think of that one is the wind speed would have to be our independent variable. So the wind is all different, right? But it does affect that category of that hurricane. Here's the last example. Oops, I showed the answer. The population of the states depends on the number of representatives that you have from the state of the U.S. Congress. So the population of the state determines, I said depends because I was thinking that way. The population of the state determines the number of representatives. How could we think of that one? Well, the population of the state determines the number of representatives. So the number of representatives is what we is our dependent variable because it depends on the population. So like Idaho doesn't have a large population, so we would have less number of representatives. Whereas a bigger state like Texas might have way more numbers of representatives. So you have to think which one depends on what. If this one depends on something, like our representatives, our hurricane category, or our calories, that is our dependent variable. And if it's kind of on its own, but it affects the other one, it's our independent variable. All right? And so I think that was the main ideas that I wanted to make sure we went over in a video.